Hi students, today we are going to take a very finest review of the kinematics. Kinematics is the language of motion. It tells us how the object is moving, how it is changing position, and we will understand the motion and all the important characteristics of motion with the help of graphs, all the key terminologies like velocity, acceleration, displacement, and I will explain you equations of motion as well as the two-dimensional motion, which includes especially projectile motion. But all of these things will be so connected, and every concept you will understand in a very streamlined way. So let's jump directly into the lesson without wasting any more time. So kinematics is the branch of mechanics in which we discuss study of motion without knowing its cause. Okay, so especially without knowing its cause, because the cause includes the external agency which applies a push or a pull on an object. Okay, so this is the kinematic. So let's first of all, let's start from the very basic terminologies like the displacement, velocity, and acceleration. So students, the first thing is the displacement. And what is the displacement? Well, that is the change in the position is called displacement. And we also can say that it is the shortest distance in the straight line between initial and final position. So that is another definition, because it is always covered in a straight line between initial and the final position. So I will give you examples to understand. So that's a displacement, and it is, remember, it is a vector quantity. So if it is a vector quantity, so its direction is always in the direction of motion. So in direction of motion. So if an object is moving in a curved path, then you have to draw a tangent at that point. So for example, if a car is taking turn like this, okay, so this is a direction of the motion of the car. So what will be the direction of the displacement at this point? So that will be along the tangent. So this is a direction of displacement vector. Okay, now secondly, as I told you, that it is the change in position. So for example, if you are standing at this position, this is your initial position at the point A, and this is your final position at the point B. So you move in a different paths. You can move in any path like this. All right. So you see, this is a path number 2. All right. So the length of the path covered is called distance. Okay. Let me write it. Length of path covered is distance, because distance is a scalar quantity, but displacement is a vector quantity. So what will be the direction of displacement from initial position to the final position? And that is the displacement vector. So what is a magnitude? How many meters, kilometers, miles that you have covered from the initial position? This is the initial position, and this one is a final position. That is the displacement vector. So students, let's take another example. For example, if this is a ball that you have thrown upward, vertically upward, so well, it will accelerate while going up. So this is a different positions of the ball. All right, and then the ball is at the maximum height. Now when the ball will be coming down, so remember, we always examine the any question of a kinematics in the rectangular coordinate system. So this is our rectangular coordinate system, in which this, the point from where you have thrown the ball is the reference point. I'm talking about this point. So if it is reaching the maximum height, okay, so let's say this height is 5 meters. So this is a displacement, 5 meter vertically upward. But let's say when the ball is coming back, okay, now the ball is turning down. So if the ball is at this position, Now you have to measure the displacement from your reference point. So displacement is still positive, dear students, and that is the upward, and that will be of course less than 5 meter. Let's say it is 3 meters. So displacement has always a it's a vector quantity, and you see it is positive because it is the straight distance from the initial to the final point in a straight line. Okay, let's take a quickly another example. If a particle is moving in a semicircle, okay, this is a initial position and this is a final position. So what is a displacement and what is a distance? So distance is a scalar quantity, it can never be negative. So length of the path, how much is the length of the path? That is equals to half circumference. So that is 2 pi r, because this is a semicircle. Okay, so that is pi r. Okay students, but what is a displacement? So once again, displacement should be in a straight line. So that is basically this one. So if this is a radius from A to center and this is also radius, so the displacement vector is equals to 2r rightward. Rightward is the direction. Okay, so anyways, I hope you understand between the difference between the distance and displacement. Now let's talk about quickly velocity and then acceleration. So student, next is the speed versus velocity, right? We had already made our understanding about the displacement and distance, so we will keep continuing. So this speed is in fact about the rate of change of distance, and remember that it is a scalar quantity. So rate of change of distance, it tells us that how fast an object is covering distance, how many meters of distance it is covering per unit time. Whereas the velocity is basically the rate of change of displacement. So when we represent it, like, it is equals to delta s over delta t. Here the s is the distance covered, whereas this is a vector quantity, so that is equals to the rate of change of displacement. We will understand all of these definitions in a graphical perspective also. Very soon, I will make a separate portion for all kinds of graphs. So this is a velocity, and you can see that both have the same units. And what are their units? That is meter per second. Okay. Now, the common thing is the unit, but it is a scalar quantity, means it doesn't have any direction, and that is of course a vector quantity. Now students, so here I want to give you the two examples. In a one example, let's say if this is a card which is traveling a equal distance in equal interval of time, let's say uh, 4 meters in every 1 second. Okay, so this will be some, these will be the positions of this card. Okay, and when we will draw its graph, so students, let's say this is a displacement time graph. Okay, so what points will you take? So we will get these points. Okay, you see that after every next interval, I mean it is covering the same amount of distance. Okay, and if I join all of these points, so then this will be the graph of the uniform motion. So basically I wanted to explain you a uniform motion with the help of this diagram, in which the displacement is changing at the same rate as the time changes. Okay, and but now this time I'm going to show you another example that is a non uniform motion in our daily life. Okay, so just imagine that this is a ball which has a 0 meter per second speed at this moment. You have released it from the rest. So how it will fall? Well, if you detect its motion from the very sensitive camera, so you will see that in every next second it will cover more distance. Okay, so this is called non-uniform motion, because displacement, we have seen in the previous graph, was increasing at a constant rate, but not in this one. Okay, so for this kind of motion we always get a curved graph for a non-uniform motion. And by the way, this is the free fall motion that I will cover separately. So if I will try to draw its graph, dear students, so its graph will be certainly how it is, because it is changing its displacement like this. So we are taking the displacement on the y-axis and the time on the x-axis. So you see it is the parabola, and how it is increasing in every next interval. It is becoming more and more steep. Okay, and I will separately explain you how, what information do we get from the graph. There are a lot of things to come. So now let's move towards the very important terminologies, like which we call instantaneous velocity, okay, as well as the average velocity. Okay, so what is the difference between these two? So students, what is the instantaneous velocity? Okay, so instantaneous velocity or instantaneous speed, I will tell you from the graph separately when I will go to that portion. But remember, the velocity at any instant of time, at specific instant of time, okay, is called instantaneous velocity. Okay, don't go anywhere. You have seen the graph, I mean this motion. If I say that it is moving with the speed of, let's say, 10 meter per second. Okay, so if it is a uniform motion, so it means that its speed will be constant, its velocity will be constant if its direction is also not changing. Okay, so at all the positions its speed will be 10 meter per second. So in this case, dear students, the velocity at any instant will be 10. But look at this. You remember I told you that we have released it from the rest. But what is the velocity? In fact, the velocity at this point is downward, and this velocity is a vector and that is increasing. So that's why I'm showing you the longer arrow every time. So this longer arrow shows the increasing negative velocity. So in this case, the instantaneous velocity will be different, and we will use equations of motion to find out velocity at any point in the non-uniform motion. So that is the instantaneous velocity. But when we talk about the average velocity, so dear students, the definition that we made, you remember what was that? The rate of change of the displacement. This is also called average velocity. Okay, so I write it again, rate of change in displacement. In the same manner, remember that if you are asked what is the average acceleration, so that will be the same according to the same, you have to apply the same thing basically. Rate of change of velocity is also called average acceleration. So why do we say it is a rate of change of displacement? So let's say students, this is once again the displacement time graph, because right now we are discussing velocity. So you can get the velocity from displacement time graph. Okay, so if I draw this graph, I'm sure that you will be familiar from this graph. Okay, this is the graph of the non-uniform motion. The ball, if you release from some height, this will be the graph. In absence of air, this will be the graph of that ball. Okay, but I will tell you separately, if you throw a ball upward, then what will be the displacement time graph? We will see that later as well. Now my right now focus is to explain you what is the average velocity in this graph. So if you see, this is an initial point. Average velocity is, in other words, you can also say the average velocity is the total displacement covered divided by total time taken. Okay, that is called total time, because whenever we measure the average velocity or average other term like average acceleration, so we are basically focusing on the initial point from where you started your motion and the final point where you ended the motion. So in this duration, how much displacement you have covered? So let's say if I assume that, let's say if this displacement covered is 100 meters, okay, and how much time when you stopped? It was 10 seconds. So according to the definition, that will be 100 meter over 10 second, that will be equals to 10 meter per second. And student, in other words, if I draw, just imagine if I draw a imaginary line. Okay, this is not a real line, this is not a graph of motion. I'm just trying to show you that what we have find out, we have indirectly find out. Don't you think if I say that we have find out the change in quantity taken on y-axis divided by change in quantity taken on x-axis, in other words delta s over delta t. In fact, this is a gradient. Okay, this is the gradient. So if you find the gradient, so 100 meter over 10 second is the same answer. Okay, so what do I conclude? That if you find the rise over run, okay, what do you find? Delta s, and you find the delta t. This is the rise over run, this is the gradient. So can I say that the average velocity, so dear student, average velocity is the gradient of the graph, gradient of st graph. Okay, so if you understand what is the average velocity, how do we measure from the graph? We take initial point and final point and we find rise over run. But might be you will be thinking, how do we find instantaneous velocity from the graph? Students, we, if you want to know what is the velocity at this instant of time, which is obviously I think the 7 second, at the 7 second what was the velocity of that object which is moving non-uniformly? Let's understand it in the graph portion. So students, if we go to the graphs, graph is very important. You will just not understand in kinematics, but you have to use it in many other topics, in fact in the entire physics, but also in the other subjects. So whenever you deal with a graph, either multiple choice questions or a structured long question, remember that in the graph we only discuss in the physics basically two things. The one is called area under graph, that's the important thing, and the second thing is we will discuss gradient of the graph. So students, let's start from the gradient of the graph, and which we can also say in mathematics or even physics we also call it slope of graph. How do we measure it? I have already told you in fact, but right now we will understand it in a structured way. Well, there are two kinds of graphs: the straight line graph, okay, and the other one is the curved graph. Okay, it depends that how an object is moving, how it is covering displacement, how its velocity is changing in a uniform rate or non-uniform rate, that decides that what will be the graph. So if we assume that our graph is straight line, now it can be any straight line. Students, it can be like this, you see, it can be a straight line of any steepness. Okay, but remember, how do we calculate the gradient in a graph? So let's say, well, this is a graph, okay? And for example, it is the velocity time graph, right? Okay, so what information can we get from it? You can, first of all, how do we calculate the gradient? We can take any 2 points on the graph. It can be the initial and the final, or it can be any point on this graph. So overall, what is a rise? Because the gradient is basically equals to the rise over run, means the change in quantity on a y-axis divided by change in a quantity on x-axis. So it tells us that how the quantity on y-axis, if it is velocity, then velocity, or if it is displacement, how that quantity is varying with respect to the quantity taken on x-axis. So if it is the graph of velocity time graph, then its gradient will be delta v over delta t. So delta v, this is a delta v, which is, I'm saying it is the rise, okay, rise, whereas dear students, this is a delta t, okay, the total time taken. So delta v over delta t is, you know, that it's acceleration. Okay, so if your graph have any straight line like this or like this, remember that as the line is becoming more steep, as we go for In a more towards more steep graph, remember that gradient increases. Okay, very important point, gradient increases. Okay, why gradient increases? Because for a more steep line, there will be a greater change in the y, and there will be a less change in the x, right? Don't you think that this is a change in y and this is a change in x? So when you will divide them, gradient will give you a larger answer. Okay, now let's go towards the curved graph. So curved graph, once again, let's take a velocity time graph, or in fact, let's take a displacement time graph, because I was explaining your displacement time graph in the velocity section. And you remember I have drawn this curved graph, and I also told you that this represents the non-uniform motion. Now, if you remember, I was telling you that if you want to find out what is the velocity at this instant of time, so how do we measure it? We will measure, dear students, by drawing a tangent line. It's a very important point. Please notice that we always draw the tangent line. So this is a line that is touching only that point. Now, once you have drawn this line, now you have to find once again rise over run. Okay. So rise over run means what is the change in this delta S, and what is a change in this, that is delta T. So if you divide these two values, that will give you the instantaneous velocity at that point. So that is delta S over delta T, but that is not average velocity. It is the, let me write it. So this is the gradient or slope of a tangent line. That's why if you see this curved graph, this tangent line will change. So students, what I specifically means that if I draw a tangent at this point and at this point, all of these tangents will have a different steepness. Okay, so all of these tangent lines will have a different values of gradient, which shows us that the gradient is changing. In fact, gradient is increasing, let me tell you. So we see the tangent at this point is making an angle of 26 degrees. Okay, and tangent at this point is making almost at an angle of 44. All right, almost. And the tangent at this point is making angle of 61. So we see that the line is becoming more and more steep. So if this is a point A, this is a point B, and this is a point C, so you can clearly see that the slope or the gradient at the point A has a minimum value. Can I say that? And the gradient at the point B is more because this tangent line is more steep. So it means that, in other words, the velocity at the point A is minimum, and the velocity is, as you see with the passage of time, is increasing. This information is extremely helpful for you. Remember that whenever you will be dealing the curved graphs. Okay, so if the line is becoming more steep, which means the gradient is increasing. Okay, now, so students, let's talk about now the area under the graph. Okay, now, whenever we deal any graph in which we have to find out area under the graph, basically we are multiplying the two quantities. In the gradient, we divide the change in y divided by change in x, means rise over run. But if I generally explain you that what is the area under the graph, okay, so that is basically the quantity taken on y-axis multiply by the quantity taken on x-axis. Okay, right? This is a separate discussion that this area may have a formula. Okay, if your graph is a proportional line and the area under the graph is the area of a triangle, then of course you will apply the formula for the area of a triangle. If it is a trapezium shape, then you will apply the trapezium formula. But overall, if you also see the units of the area under the graph quantity, then you will see we basically multiply y and x. I give you example. So students, let's say if this is the velocity time graph, right? So the area under the velocity time graph is very important. Okay. So let's say if this is a graph which is representing a constant change in the, the velocity is increasing at a uniform rate, and then velocity is constant for some time. Okay. So now if you see that, how do we measure the area? So either you can apply directly the formula of the trapezium. Anyways, what we actually understand that this is the area under the graph, and this is the area of a triangle. So this is the area of a triangle. So that is 1 over 2 into the base of a triangle. Look at the unit, 3 second, and into the height. So that is a 10 meter per second. So even if you check meter per second is multiplied by second, so which will give answer in meters, which means it is the displacement covered. Okay, plus now the area under this rectangle, so that is equals to the base, that is 3 seconds, into the height, that is 10 meter per second. So you can calculate it. It will be simply how much, 30 over 2, that is 15 meters, plus 30 meter, so that is 45 meter is the displacement covered during this. So students, this you have seen that this is an important example in which we have learned that if your graph is the velocity time graph, so area under velocity time graph is equals to displacement covered. And here I specially mention that if your graph is the, they mention that this is the speed time graph, now the area will be the distance covered. Okay, now the next important example is the acceleration time graph. Okay, anyways, acceleration is, so this is obviously the rate of change of velocity. So if the velocity is changing, and the velocity will change of course actually due to the force, right, which we will cover in the next unit. So rate of change of velocity, which means that acceleration is equals to delta v over delta t. Now once again, that velocity can change at a constant rate. It can be a straight line graph or it can be a variable graph. In which case it is a variable graph if a skydiver is jumping from airplane, and in the presence of air resistance, what will be the graph? That will be a curved graph. So students, if this is the velocity time graph, then how the velocity of skydiver actually varies? So because now if you include the air resistance, so what will happen with the passage of time, the force applied by air on the body of skydiver or any object which is moving and experiencing the air resistance, the drag force increases. So due to which this is basically the graph. So at some time the object attains the constant velocity. It's important to know that this velocity at this instant of time, this velocity is called terminal velocity. Okay, so terminal velocity means when the object attains the constant velocity. So you have seen in this graph, this is not a straight line graph. So it means that if I draw the tangent at these points, so you can see the tangent is becoming less steep, less inclined. So can I say that acceleration is decreasing? I hope you understand that at this point it is more value of rise over run, but at this point less value of rise over run. And in fact, at this point, acceleration is zero because, dear students, you know acceleration is the gradient of velocity time graph. And why I'm saying it's a gradient, because don't forget the formula of the acceleration, delta v over delta t. So what quantity you are taken on y-axis, that's velocity, and time on the x-axis. So acceleration is always gradient of velocity time graph. So this is a graph of the, once again, non-uniform motion. Now let's go back here, acceleration time graph. It was important to tell you first about the acceleration. Okay students, so we always measure acceleration in fact in the meter per second square and the time in second. So now whatever the graph is, okay, it can be any graph. Let's say Let's take a very simple example. It is like this graph. Okay, now the area under this graph, so even let's take the values. For instance, it is 5 meter per second square. Okay, and for this is 10 seconds. So an object move with a constant acceleration for 10 seconds. What is this area represents? So it is obviously the area of the rectangle, and if I multiply and if I apply the formula of the area of rectangle, so just look at the units. What I told you in the start, area is actually indirectly multiplication of two quantities. One is on y-axis and the one on x-axis. So what we see is the 50 meter per second. Now dear students, this is not velocity. It is change in velocity. Okay. Why? Because if you see the formula of acceleration is equals to delta v over delta t. Okay, so if you take the delta t on the other side, okay, so a multiplied by delta t is equals to change in velocity. And this change in velocity concept is used in many questions in the past papers. If an object has started from 0 meter per second, and what will be its velocity at a certain time, in that question you have to apply this information. Okay, so now I'm going to draw such a table that will be very helpful. Okay, so students, let's quickly summarize. We have the three graphs in the kinematics. The first is the displacement time graph. Okay, so the displacement time graph, what we have learned so far in the displacement time graph, that the gradient is equals to delta s over delta t, which is equals to the velocity, and this velocity can be instantaneous and average depending how you are calculating it. In fact, there is a no physical quantity which represents the area. Okay, no physical quantity, there's a no meaningful physical quantity. You can consider, if you multiply meter with second, meter second is no physical quantity that we learn. Okay, now next graph is about the velocity time graph. If we measure the area under the okay, let's talk about first the gradient. So delta v over delta t is the acceleration. Once again, it's instantaneous or average, depends how you are calculating at a point, or you are finding out the total gradient. Okay, and what is the area? Area under the velocity time graph is equals to the displacement covered. So v multiplied by delta t is equals to s. So it is basically the displacement curve. Last but not least, acceleration time graph. An acceleration time graph is, there's a no physical quantity that exists which actually tells us about the gradient. Okay, but if we multiply acceleration with the time taken, so that is equals to change in velocity. Okay, so change in velocity. Okay students, so we are not getting slow, rather we are entering into another phase of very important discussion. And well, I'm going to draw so many graphs that will cover almost entire thing. Okay, so you see that basically, so students, in this portion now I am going to draw many graphs which will describe the different motions, and almost everything that you will see in your incoming test, in your assignment, in the book, the famous graphs. So this is the displacement time graph, this is the velocity time graph, and that is acceleration time graph. So what we are going to see, the different types of graphs. So students, first of all we will discuss an object which is at rest. So what will be the all graphs? Displacement time, velocity time, and acceleration time. So if an object is at rest, so remember that its displacement time graph will be always like this horizontal line. Okay, so this is a ST graph, and you can see that why it is like this, because it is a horizontal line and the gradient of this graph will be, you can see that delta s over delta t is equals to 0. So which means that the velocity is equal to 0. So when we will draw the velocity time graph, so you can see that for the same time, your graph will be like this. And of course, if the velocity is not, I mean, velocity is 0, so it means there's a no acceleration also. So students, now let's move towards the uniform motion. And we had already seen in today's lesson that if this is a straight line graph, then it means that it tells us that how the displacement is increasing with respect to time, that is actually at a constant rate. So in this case, we have seen that what will be the velocity will be a some constant value, so this will be always a graph. Now remember, if I increase or if I change the steepness of the line, let's say this one, so now it will give us more value of velocity. Okay, so let's show us like this. So this will give us this value. Okay, now what will be the acceleration? So acceleration, if the velocity is not changing, so don't you think delta v over delta t, which is the acceleration, so acceleration will be 0. So it means that we must show no acceleration because the object is moving with the constant velocity. But remember that it is not necessary that you will always see this kind of graph in exam. This line can be decreasing as well. So students, let's say if this is our displacement time graph and the object displacement is changing like this, what it tells us that displacement started from the maximum positive and it is eventually becoming 0. Okay, which means that the object is returning to its reference point. You got it? Returning to its original position. So in this case, velocity is negative because if you will find the slope of this line or the gradient of this line, it will always give you the negative value. Why? Because look at the change in displacement. The displacement is changing but negatively. Okay, it is decreasing. The final displacement is less than initial displacement. So in this case, dear students, we will always get the negative velocity time graph. So this is a velocity time graph. But still, we see a constant velocity. It means the change in velocity is 0 with respect to time. So that means that acceleration time graph will be still no value. Okay. So this was another type of the uniform motion graph, and in which whenever our displacement time graph is a straight line like this, velocity of that object will be constant. Okay, students. So if imagine this is this is a graph, right? It means that now the displacement is decreasing more in a more steep sense, means it is decrease, there's a more decrease in displacement with respect to time. In the less time there is a more change in the displacement, but which means that the object is moving with a more velocity, but which velocity? More negative velocity. So you see that I am showing you the more velocity, but it's still negative. So which means that the gradient of this graph will be also negative, but in fact the more negative value because this line is more steep. Once again, acceleration is 0. Now if your graph is like this, okay, starting from this position, okay, it is, imagine that you are standing on a hill or you are standing on a floor of the building and you have just released the ball. Okay, so in this case, I am considering the origin or the reference at the surface of the building. So if the ball is going downward towards the ground, it means that the displacement is increasing but negatively. In this case, again, dear students, velocity will be constant and in fact it will be negative once again. Okay, and acceleration is 0. You know this. Okay, now let's talk about the curved graph. So students, let's categorize now. This is our non-uniform motion. And in this student, we are going to cover especially UAM case, that is uniformly accelerated motion. So students, first of all, I'm taking a special case of the uniformly accelerated motion. Let's say if this is a ground and you throw a ball vertically upward with some initial velocity u, right? So how the ball position will change, ball will, in every next interval, ball will cover less distance, and eventually at the maximum height will stop, and then it will return in the same manner. So if we draw its graph, then what will be its displacement time graph? So students, in this case, remember one thing, that acceleration is only due to the force of gravity, and the force of, that's why it is constant, negative g. It is a constant value, negative 9.8 meter per second. Negative is just because the acceleration direction is downward. And why it is negative g? Because only one force will be exerted on this object, that will be the force of gravity. This is called free fall motion. And if you are throwing a ball upward, the ball will take same time to come back. So what will be its graph? So dear students, remember that its graph will be the this one. And why I'm saying like this graph, because you can verify that if we draw a tangent at this point, and we see in the start the tangent is maximum steep, which means the velocity was maximum, and at the maximum height, look at the tangent, which means the velocity is zero. Okay, so it means that in the velocity time graph, we can start the graph from some maximum positive value, which is the initial velocity, and then we can take it down like this, and this is in fact the time when it reached the maximum height. So then what happened after that? Now if you draw the tangent line at this point, look at this. So you see that now this tangent line is giving us the negative value of gradient, negative value of slope, as well as this tangent line is becoming more steep, which is clearly indication that this graph, this velocity time graph, is still continuing, and this is the velocity time graph, not the speed time graph. So it can be negative. The speed time graph will be like this. Okay, so don't forget, acceleration is due to gravity is negative g. So that's why it will be a negative value, okay? And that's a constant. And also it is constant because velocity time graph is straight line. So students, let's quickly discuss the other curved graph. So for example, if this is a graph of the displacement time, right? So you remember we had already discussed the graph of velocity time graph of his skydiver. This is the same shape, okay? So we will treat in the same manner, that if I show you the tangent line, that how the tangent line slope is decreasing, and in the start the tangent line has a maximum steep. Okay, it's a maximum steep, so it means that velocity overall is decreasing but not becoming negative, right? So it means that our graph should be like this. Okay, at some point it will be negative, become zero. And what will be acceleration? Since this kind of graph always gives us a negative value of slope or the negative value of gradient, okay, because velocity is decreasing, that's why, dear students, acceleration time graph must be like this constant line. Okay, and if your graph is, and for example students, if our velocity time graph is curved, okay, so the concept is same. If this can be like this curve or this can be this curve, the concept that we will apply is same. Okay, so what is the concept? It, in the start, if you draw the tangent line, and acceleration of this tangent line will be, gradient will be zero, it means that acceleration should be zero at the time t is equal to zero. And as the time goes on, we see that the line is becoming more steep, but also give us a negative value of acceleration. So it means that students, acceleration is starting from zero, but how it is changing? It is changing like this. Okay, so it is increasing. So this is a acceleration time graph. So students, this is all about the graphs and all the other quantities. Okay, but this is not ended here. I'm going to explain you in the next video about the equations of motion, special cases that will help you a lot in the multiple choice question especially, and how do we apply equations. And then most important, we will cover projectile motion. There are a lot of things that I will cover after this, so don't skip the video.